Okay, so now knowing that if we have two line segments with equal slopes, they're parallel, or if we have two line segments that are parallel, their slopes will be equal. Knowing that information, which is basically just saying the backwards version of the same statement. It's called saying the converse, actually, if you wanted to really get technical. But knowing that, let's have a look at the example here. Determine whether the quadrilateral with vertices or a vertex is a fancy word for a corner. DOGS is a parallelogram. So remember that a parallelogram has four sides, opposite sides being parallel to each other. Okay? Well, how can we determine that? Well, now knowing what we know about slope, we can very easily calculate the slopes between some points and determine if it's a parallelogram. So we plot the points. Negative 6, let's go to this. Negative 6, negative 6, 1. Here's point 1. D. Negative 2, negative 6. Negative 2, negative 6. Point 2. O. 11, 2. 2, 4, 6, 8. 2, 4, 6, 8, 10, 11, 2. G. And 7, 9. 2, 4, 6, 7, 2, 6, 8, 9. Yes. Is this shape dogs, is this shape a parallelogram? In order for this shape to be a parallelogram, this line has to have the same slope, be parallel to this line, and this line has to have the same slope or be parallel to this line. So we can very quickly calculate that. Is DS and OG, are DS and OG parallel? So now we have to go back here and we calculate the slopes. DS. So now we're going to calculate slope between D and S. Go to our formula. y2 minus y1 over x2 minus x1. I'll write the formula down here for the first one. You should always be in the habit of writing the formula down anyway, so that you can follow your work properly. And I'll label these the first time around, but after that, just for simplicity and speed for the video, I'll stop. I won't write the formula again. So y2 minus y1 is going to be 9 minus 1 over 7 minus negative 6, which is going to be 8 over plus is going to be 13. 8 over 13. That's ds. So now I need to look at, in order to compare this, I need to look at OG. So now I'm going to look at OG to see if they're parallel. OG. M is equal to y2 minus y1, 2 minus negative 6 over x2 minus x1, 11 minus negative 2, which is going to be 8 over 13. So ds is parallel to OG. Just calculated that. Now I check the other ones. I check DO and GS. DO, the slope is equal to DO, which is D and O, negative 6 minus 1 over negative 2 minus a minus 6, which is going to be plus a negative 7 over plus a positive 4. Negative 7 over 4. And then I look at, what's my other one? SG. Slope between S and G. SG. M is equal to 9 minus 2, 7 minus 11. 9 minus 2 and 7 minus 11, which is 7 over negative 4. And just because the negative's on the bottom doesn't mean anything, because we can rewrite that as negative 7 over 4. So both of these are also parallel. Oh, what am I doing there? Both of these are also parallel. So DO is parallel to SG. Now because those two sets or pairs of lines are parallel to each other, then the quadrilateral, come on, that's right, quadrilateral DOGS is a parallelogram. Parallelogram. Now, the rest of the examples, maybe I can do this one right here. Over the page, plot the following grid. Plot the following on the grid. A, 6, 2, B, 10, 3, C, and D. What do the two lines have in common? Determine the slopes of both lines. A is 6, 2, 2, 4, 6, 2. Whoops. 2, 4, 6, 2. There's A. B is 10, 3, 6, 8, 10, 3. There's B. There's my line segment. AB has a slope of 3 minus 2 over 10 minus 6, which is equal to 1 over 4. And then CD is 3, 2, and 2, 6. CD 3, 2, and 2, 6. This line segment here, CD, slope is equal to 6 minus 2 over 2 minus 3, which is equal to 4 over negative 1, or just negative 4. But I'm going to erase that negative 4 just so we can have a better look at this a little bit right now. What do the two lines have in common? Well, if I were to extend these two lines, well, I'll use a different color. Let's use red. If I were to extend these two lines, something like that, and blow this up a lot, what does it look like to you at that intersection? Well, hopefully you say, well, it looks like it might be a right angle, meaning that this would measure 90 degrees. And that's actually what it's supposed to look like. And I'll explain to you why in a moment here. So it looks like it's a 90 degrees. If we look at the slopes of the two lines, 1 over 4, 1 over 4, and negative 4 over 1. These two fractions have a special relationship. One is the reciprocal. Actually, let me erase that. One is the negative reciprocal. Of the other. Now, a negative reciprocal is changing the sign and flipping the number over. So the reciprocal is flipping it, and the negative part just means change the sign. So it goes from positive over here to negative over here. And then, of course, it also flips. 1 over 4 becomes 4 over 1. Negative reciprocal slopes are what we call perpendicular. Perpendicular, which means they form 90-degree angles with each other. Perpendicular. And that's what these phrases here say. This is what it was hoped that you would discover. If the slopes of two line segments are negative reciprocals, the line segments are perpendicular. Or saying the converse, if two line segments are perpendicular and neither one is vertical, their slopes are negative reciprocals. Don't worry about this negative, neither is vertical for a moment. We'll talk about that probably later, maybe in class. Okay? So it's saying that AB is perpendicular to CD. So it's like an upside down T is the symbol for perpendicular. All right, and we'll come to the we'll do the examples in a quick second.